This conference will now be recorded.
Good afternoon, everyone. Welcome to the Southern Alberta ITE June webinar. We ask everyone to please mute your mic during the course of this presentation. There will be a question and answer period at the end of the presentation, and we ask you to please utilize the chat messaging function for the questions. Just before we get to the presentation, a few intro slides. That's this. First of all, a big round of applause to Southern Alberta ITE for winning the 2021 CITE Outstanding Section Award. Southern Alberta ITE won the Moment Award back in 2019 and the Outstanding Section Award in both 2020 and 2021. So the award is to recognize the overall quality of section activities to promote the purpose and objective of the Institute. So congratulations and a big thank you to the Executive Committee, as well as all the members and non-members that attended the events through the year. Just another note, ITE is holding a third and final transportation equity listening session. These open forums are to help ITE to identify what resources ITE can provide on this topic. And they're looking for input on where ITE should lead, where they should be collaborating, and where they should be monitoring. So if you have a chance, please register and attend one of the session or this last session if you haven't already. Just a heads up that our next Southern Alberta ITE webinar will be in July, and the presenter would be the ITE Urban Goods Movement Committee, and they'll be presenting on the urban goods movement and curbside management. So just a quick note to stay tuned for that. So today's presentation is on the Deerfoot Trail study. Deerfoot Trail is Calgary's oldest freeway and the busiest in Alberta, primarily built between 1971 and 1982. The highway provides an efficient, reliable, and safe connection for motor vehicles and good movements within and to and from the city. Since 1981, Calgary's population has pretty much doubled, and the aging infrastructure is no longer meeting the current travel demands. And this results in congestion, unreliability, and safety concerns. Since 2016, the City of Calgary and Alberta Transportation have been working together to study Deerfoot Trail from Stoney Trail north to Stoney Trail south. This is approximately 35 kilometers and includes 18 interchanges and a feature one at the 128th Avenue Northeast. Today, we have two presenters coming for us. Let me see if I can advance the screen. So we have Jeffrey Hsu from the City of Calgary, the project manager. He has over 25 years experience of planning, design, construction, and project management, and has worked for consultants, Alberta Transportation, and the City of Calgary. He joined the city's transportation planning group in 2013 and delivered successfully major studies, including the 16th Avenue Northeast Functional Planning Study, Airport Trail Upgrades Functional Planning Study, and the Glenmore Trail East Functional Planning Study. He is currently working closely with Alberta Transportation on the Deerfoot Trail Short-Term Improvement P3 project. Next, we have Ken Curry, VP and Manager of Traffic and Transportation Planning with Parsons. He has over 30 years of planning, traffic engineering, and design experience across Western Canada and the US. He has participated and led a wide range of multiple disciplinary functional planning and design assignments, ranging from large corridor planning studies, interchange functional designs, through to ITS applications, including several reversible lane systems. Ken led the transportation planning and traffic engineering input for the Gateway program in the Metro Vancouver region. which involved widening of Highway 1 over 35 kilometers and upgrading of 18 interchanges. This project provides relevant background for the recently completed Deerfoot Trail study, where Ken provided technical direction. Now go to the presentation.
Thank you, Lou. Hi, everyone. I'm Jeffrey Xu, Project Manager of the Deerfoot Trail study. Can you hear me good?
Yes.
Thanks. The study is a joint study between the city and the Alberta Transportation to improve traffic operations and safety along the corridor and adjacent road network in the long term. With me today is my colleague from Parsons, Ken Curry. He will present the study process and option evaluation later. Next one, please, Lou. Today's topic includes the study corridor, study purpose, study process, option evaluation, and the preferred long-term plan. Next slide, please. Deerfoot Trail is a provincial highway. It's under the jurisdiction of Alberta Transportation since 2001. In Calgary, Deerfoot Trail is part of the primary goods movement network, and it is classified as a skeletal road. The average daily traffic ranges from 83,000 vehicles per day at the south end to 170,000 vehicles per day north of Memorial Drive. It's the only road other than Stoney Trail, providing continuous north-south connection across the city, and the only north-south skeletal road serving central and east Calgary. Next one, please. The principal role of the Deerfoot Trail within the city is to provide an efficient, reliable, and safe connection for motor vehicle traffic and goods movement within, to, and from the city. The purpose of the study was to review and develop short, mid, and long-term recommendations to enhance safety and mobilities for all users, and improve traffic operation throughout the corridor and adjacent network over the next 30 years. Now I will hand it over to Ken. Next slide, please.
Thanks, Jeffrey. So I'm going to go through the study process, and in this one, a big study, we had several key steps. And so the first step was kind of putting together an existing and historical context report. So this was a big data collection exercise and really documenting what's out there. Then we went through extensive work, and we'll talk about that a little bit later, of the problem definition report. So a lot of analysis of existing and future conditions. We've developed an evaluation framework for assessing the concepts near the end of the study. We developed improvement options, so that was a major undertaking, and we'll talk about that today. Went through a key step of option evaluation and recommendations, and so given the length of the corridor, there was quite a few recommendations throughout. And then there was the final step, which was putting together the final report and kind of an online public information session. Next step. Next slide. So this kind of gives a kind of a graphic of the study process in terms of phases and timelines. So it's kind of conducted over about 5 different phases with those steps. So again, phase 1 was the existing and historical conditions. Phase 2, we call it the desired performance, and this included a number of public and stakeholder engagement events. Phase 3 was where we did the option generation aspects, and again, we had quite a few public and stakeholder engagement events through that phase. And then finally, we had the option evaluation refinement, and this step, we only did include stakeholder engagement, and this is where we ran into the kind of the COVID issue at the end, at the phase 5 reporting is that the public information, the outcomes of the study were more or less relegated to be online since we couldn't have any in-person engagement. Okay, next slide. So in phase 2, with the problem definition, we went through an extensive review of the existing and future base conditions on the corridor. So we did some data collection activities, including an OD survey, and this one was done with Bluetooth readers that were installed along the corridor. So kind of old technology compared to what we do today. We developed a corridor-wide traffic operations model. So this was used to assess traffic operations on the corridor, especially into the future. We used a lot of existing data for existing conditions. We developed a series of performance metrics so that we could actually come up and tell the story of what's actually happening on the corridor. And through that, the type of analysis that we performed using the operations model, we showed the speeds on the corridor and travel time. So that graphic there shows the speeds in the corridor and where we're having problems and breakdowns in the corridor, and with time being on the y-axis and the distance on the x-axis. Then we did a bunch of highway capacity manual analysis as well. And here we were trying to pinpoint the actual causation of some of the operational issues out there. And that was related to freeway capacity, weaving, and merging and diverging. And then we also did some intersection capacity analysis at the ramp terminals and the adjacent intersections just off the corridor, because a lot of those, as many of you know, are driving some of the issues along the corridor just off the ramp terminals. Okay, next slide. And then we also did, a safety analysis of the corridor. So we looked at the crash frequency, crash rate, and critical rate index, and then crash severity. And then through that, we've identified the potential high crash locations on there and identified the potential high crash interchanges. And this was kind of a difficult undertaking, to put things into perspective, because there wasn't very many comparable corridors in the province to rate things. So what we actually did when we looked at the high crash locations and high crash interchanges is we actually because we had such a long corridor, we actually just kind of rated things within the corridor itself. So we kind of put things in a priority within the corridor and identified those high crash locations and interchanges with respect to the other interchanges from end to end. Okay, next slide. And this gives a kind of a summary of all the issues along the corridor. So there was no shortage of those. So we kind of presented these things graphically to show both safety issues, merging, diverging, capacity issues, and intersection operational issues as well. So this kind of gives it, like I say, a snapshot, and again, this shows things both in the existing conditions and in the future conditions as well. And one of the key things that I'll just put a little sidebar in here. Through the Bluetooth OD survey and a lot of the modeling that was done by the city's team, one of the key things that came out through this problem definition analysis was the OD patterns, and especially crossing the river. What we saw is that there's a lot of traffic that is using the river crossings at Ivor Strong Bridge and at the Calf Road Bridge that are primarily almost east-west traffic, but to cross the river, they're using the north-south corridor. And so we see a lot of traffic that gets on, say, at 24th Street or at Barlow and literally crosses the river and then gets off at Anderson Bow Bottom or Southland. And we see that kind of east-west traffic pattern causing a lot of problems. And that drove with some of the issues that or a lot of the options that we generated in the future, as we move forward, both at the northern part of the corridor or middle part of the corridor at the Calf Road Bridge, some of the options to look at network connections, and similar down at the this area, Anderson Bow Bottom, to look at network connections there as well to try and alleviate that east-west traffic using the north-south corridor. Next slide. So the option generation process, We had quite a extensive process that we went through. We divided into like 3 steps. So strategy assessment, concept screening, and option evaluation. And so this, kind of long-winded process for option generation was much because, we end up having a significant amount of ideas or I guess traffic management type considerations that we wanted to look at on this corridor. So, and we'll go to the next slide here, is that we had this toolbox of traffic management ideas. And, when we started the study, we wanted to explore everything. Even at the very beginning, we were even looking at tolls, but that was taken away. And so, we were left with almost about 70 elements across 6 categories in our toolbox. So we're looking at everything from traffic mobility type related traffic management tools, demand management ideas, such as HOV lanes, mode shift ideas, improving safety, so getting down to a little bit of details. We definitely had the technology application, so you'll see there's a layer in there of ITS type improvements. And then we had, kind of the general capacity and geometry improvements. So part of that whole process, as we get into the strategies, is, we went through a toolbox screening workshop, and, we kind of looked at all those problems that we had in the corridor, and through involvement from the city, Alberta Transportation, and our project team, we narrowed that 70 elements down to 41. Still a pretty big list. So the next step was to look at the strategies themselves. So definitely high level, and we came up with 5 themes coming out of that workshop. And so through those 5 themes, we had 13 strategies, so different ideas within each theme. So we had travel demand management ideas. So this is where we're looking at some HOV lanes. We had network improvement. So this is where we're just isolating, kind of improvements across the corridor, kind of to address that issue that we talked about with origins and destinations that were more east-west orientated. We had some options that this looked at general purpose capacity. Definitely the managed lane HOV capacity, and then we looked at ones that had collective distributor systems as opposed to network improvements. Next slide. So through that, the strategy assessment, the analysis methodology was more or less focused on some key criteria, all related to the ability of the analysis tool. So all this was all done at the high level using the city's M model. To look at the analysis, and we pulled out information that related to network travel time, the traffic volumes or usage, especially when we were looking at new links as network elements crossing the corridor, network travel, so looking at total vehicles, kilometers traveled in the city, volume capacity ratios on the corridor, are we making some improvements, route travel times again, and then because so much of the corridor is adjacent to the green line, we also looked at are we actually influencing or impacting ridership on the green line. The strategies definitely were developed, with the level of detail commensurate with the analysis tool, and then we worked really closely with the city's modeling team to do this work. So we would sketch up the ideas. They would be coded, we would review those, and then if everything was all A-OK, the city would model those for us. And then all the outputs were post-processed by our team, and very systematic process to populate those assessment criteria. And then through that kind of high-level analysis, we were able to remove some of those strategies that were addressing the objectives or the issues that we were trying to achieve. Next slide. So that led us to the next step, which was the concept screening. So now we're adding a bit more detail to the options or the concepts. So we're taking those ideas or those kind of findings from the strategies. We came up with 3 themes, and within those 3 themes, we had 8 concepts. And then we built those themes around HOV capacity, GP capacity, and then looking at a series of collector distributor lanes along the corridor. And then As I mentioned, the strategies were pretty high level. Now we're adding a little bit of detail into these concepts to definitely start targeting some of those issues that we identified in the problem definition and coming up with some focused mitigation measures. So these concepts definitely had more detail. So when we went to the analysis, go to the next slide. We used the same tool for the main analysis, but we added in some extra criteria to reflect feasibility. So now we're no longer working in kind of a virtual world. We're starting to look at some practicality of these concepts. So we're looking at costs, property impacts, and impacts to sensitive lands or environmental impacts. So we looked at all those together with those same sort of analysis criteria that we were using with the M model, and same methodology. And through that, this is where we narrowed things down to the 3 option packages that we went into the multiple count evaluation. Next slide. So the option packages, we broke things down. Now we could get into much more detail. So within the option packages, we had 3 layers. So we had the traffic infrastructure layer. So this is really, we're looking at physical improvements for traffic. And we are looking at, primarily with the increase in highway capacity, where we're looking at adding a general purpose lane or HOV lane in each direction. And then for interchange improvements, we were looking at various changes at the interchanges to address traffic operational issues or safety issues. So we're being now much more detailed into what each of those interchanges are potentially looking like in terms of connections. And we also have some network improvements as well, such as new connections across the corridor or adjacent to the corridor. That the next layer is in here, the active transportation. So we looked at a number of potential improvements in the corridor and primarily across the corridor to improve active transportation. So a review was done to look at all those gaps crossing the corridor. And there was no shortage of those either. In the corridor, there's a lot of structures that are out there that don't even have sidewalks on them. And there's a lot of locations where there are some pedestrian facilities, but not meeting current standards. So quite narrow, not not dealing with either cyclists or pedestrians very well. And then the third layer that we built into all the option packages was the technology application. So this is where we're looking at some ITS type improvements that would enhance the safety and reliability of the corridor in conjunction with the traffic infrastructure improvements. Okay, next slide. So this is the kind of a snapshot of the extent of the corridor when we were looking at the capacity improvements. So the HOV extents, we were definitely looking at from Airport Trail to Barlow Trail. So through the strategy assessment and the concept analysis, we more or less concluded that we didn't need to look at much more capacity beyond Airport Trail or south of Barlow Trail. And so we looked at, is that going to, that extra capacity, is that going to be provided through an HOV lane or through a GP lane? And as most of you probably know, we did recommend, that we go with an HOV lane as the primary means of adding capacity to the corridor. Next slide. And so then we get into the last kind of phase, and this is the option package evaluation. So we have those 3 option packages that we've come up with, and they were largely driven by a couple key areas within the corridor. So down at the Anderson Bow Bottom area and down in the 17th Avenue Memorial Drive area. So those concepts in those areas really drove the option packages, and then we added other commonality or common options to those packages. And then we went through a multiple count evaluation. So this is where we got quite detailed, and so we had a financial count where we looked at capital costs and property costs, the customer service account, primarily driven by the travel time savings. So this is where we use our VISM traffic operations model, and we actually assessed very detailed wise all the options in the corridor out to 2048. We looked at improvements in road safety, and pedestrian and cycling accommodation, and transit service accommodation. So, both within the corridor and across. Social community, definitely we looked at that from a, specifically from a property impacts, but also things from noise and visual impacts. Definitely got feedback from our stakeholder and public engagement, especially in areas up around Barlow Trail at South of Memorial, where some of the improvements would definitely be impacting people's viewpoints over the city, where we could be thinking about putting or widening out the Barlow Trail. So we definitely looked at mitigation measures coming back from that feedback. And then the last account was environmental, where we looked at impacts to aquatic features, vegetation, wildlife, historical resources, and then we also calculated out vehicle emissions and greenhouse gases for that as well. Next slide. And so I think this is get back to you, Jeffrey.
Yep, thank you, Ken. For the option evaluation, I just want to add one thing. For the 3 option packages, eventually we recommended the option package 1. And here we go. This is the preferred long-term plan. So as Ken mentioned, the preferred long-term plan recommended HOV lanes from Barlow Trail to Airport Trail, and some significant improvement at many interchanges and the key areas. The green circled locations are the areas to be improved, including interchanges at 128th Avenue to the north, further down to the south at Anderson Road and the Beaubarton area. The preferred long-term plan has the least property impacts and the least environmental impacts when compared to other alternatives. I will quickly go through several improvement plans at some key locations. Next slide, please. This is at Glenmore Trail interchange area. The main issues here include lack of capacity on Deerfoot Trail and high weaving traffic volumes in this area due to the interchange configurations. There's no northbound to westbound movement provided today at Glenmore Trail interchange. We propose redesigning the Blackfoot Trail interchange to reduce weaving traffic in this area by reconfiguring the Glenmore Trail interchange to provide all movement with directional ramps. This will reduce congestion on Deerfoot Trail from the northbound Heritage Meadows Way off-ramp. Next one, please. This is the future 50th Avenue Southeast connector. Today, between Glenmore Trail and the 17th Avenue Southeast, there's no east-west connection. People take Deerfoot Trail to cross Bow River. This new connection will improve traffic flow by removing some local east-west traffic from Deerfoot Trail. In the meantime, it could potentially free some potential capacity on Deerfoot Trail mainline. Next slide. This plan is along 16th Avenue from Deerfoot Trail to Barlow Trail. It shows network improvements that include adjacent intersections. We plan to upgrade 19th Street intersection to an interchange to remove existing bottlenecks. These are complex interchange improvements due to the close spacing of the 19th Street intersection to Deerfoot Trail and Barlow Trail. Next one, please. Here is the 17th Avenue and the Memorial Drive area. We propose to remove the south-facing ramps at Memorial Drive interchange to get rid of the weaving traffic between Memorial Drive and the 17th Avenue. The traffic using south-facing ramps will be directed to Barlow Trail. On the right-hand side, you can see the plan. to access Deerfoot Trail via 17th Avenue. This will provide a direct connection between Blackfoot Trail and Barlow Trail. The Deerfoot Trail main line will be widened to 4 lanes in each direction. Next one, please. Here is at Anderson Road, Bow Bottom area. The main issues here include many local east-west traffic. Again, use Deerfoot Trail to cross the river. The weaving traffic at the entrance and exit ramps created capacity issue, and there isn't enough capacity along the Deerfoot Trail main line. We would start the new road facilities to separate the local east-west traffic from the mainline through traffic. A city system as shown in purple color will move vehicle lane changing away from Deerfoot Trail mainline. There are extra lanes separated from the Deerfoot Trail through traffic. New bridge will be built over the Bow River, and a direct connection from Blackfoot Trail to Anderson Road will be provided on the north side. Next slide, please. As Ken mentioned a moment ago, the second layer we considered was active modes for people walking and cycling to cross Deerfoot Trail. In the long term, we plan from 128th Avenue Northeast interchange to Mackenzie Town Boulevard interchange. Pedestrians and cyclists crossing Deerfoot Trail will be improved at each single interchange, either by providing a new multi-use pathway or by upgrading the existing facility to a new map. Next one, please. The third level we consider is ITS application. In the short term, we recommended continuing to use advanced traveler information systems and improve the incident management system. In the midterm, we recommended a queue warning system, and for the long term, we recommended lane management and speed harmonization. I believe this is pretty much about that. Next one. This wraps up the whole presentation. We are happy to take your questions. Thank you.
Thank you, Jeffrey and Ken. Any questions, please use your chat functions. Basically, there's one question. Based on ME model, how significant was the impact of additional general purpose HOV lane on transit network?
Actually, we found that the impacts were not that significant. So when we started looking at between the options, we didn't see a whole reduction, that much of a reduction in ridership. There was a reduction in ridership a little bit, but it wasn't that significant. So that criteria became kind of a bit of a wash through the comparison.
Great. Just a simple question. It says that in this technology slide, there's an acronym, and that was CMS. Did you define that?
CMS, that's changeable message signs, or it could be dynamic message signs, just depending on what's driving that. So just definitely having some electronic boards out there to disseminate information to drivers.
Question from Ryan. We have heard a lot about induced demand. What is the lifespan of this ultimate plan?
Well, we did all the analysis out to 2048, and so we look at the demand in the quarter that we're kind of predicting or forecasting up there. But as I was watching through the slides that Jeffrey was presenting at the end with the ITS, The ITS is really, you see that we're recommending some things like queue warning and a few things like that into the future. We do predict that even with an extra lane on the corridor, that there will still be some pockets of congestion out in the future. There's some places with high entering volumes into the corridor, so we do think that there will be still areas of slowdowns, and therefore the need for technology to come in to help improve reliability and safety, through management of the overall network, moving people between Stoney Trail and Deerfoot, as well as giving people advance warning of potential slowdowns ahead, so that we don't have any safety issues with queue formation and collisions.
Question from Jack. Can you discuss the decision to leave Cathro Bridge versus replacing it with a straight bridge?
That was getting pretty much driven by all the works that the city has going on with a lot of the, I think the water treatment in that area, and the lack of the corridor availability. So when we were looking at some improved alignments of Deerfoot, we were running into a lot of conflict areas on both sides of the river with respect to parks and the water treatment areas. So we ended up looking at this and saying that it's probably best to stay within the existing corridor, and this widen the existing bridges, or depending on what further preliminary detail design dictates, might be replacement of those bridges.
Yeah, I just want to add a little bit here, Ken and Lou. We have lots of constraints at this 50th Avenue alignment location. On the plan, we can see the blue circled area, that's the future water facility, a future pond. And further west, you can see the green dashed line, that's the future LRT. And on the east side of the river, there's the land was a very sensitive land, have some environmental issue. And on the very west side, just below the future 50th Avenue, that site is reserved by the city's Calgary Transit for their future facilities. We have lots of constraints here, and that's why we eventually dropped the one option where we plan to have a straight bridge for the future Deerfoot Trail.
Great. Thank you, Jeffrey. Next question from Chris. One of the slides showed a northbound access from Maxwell Arena going beneath Memorial up to Century Gate Southeast. Is this meant to reuse the existing closed off underpass currently beneath Memorial?
Yes. Yeah. So with that concept, the existing access to Maxwell Arena would be disconnected from Barlow and moved down south to 17th. So it definitely was an issue that we were restricting, or definitely impacting access to the Maxwell Arena complex, especially given that there's other things that go on there, a lot of summer park activities. So it was requested that better access be examined, and so we looked at coming up from the north and repurposing that abandoned tunnel with a local access road that takes us out to Barlow Trail north of Memorial Drive.
Great. Question from Chris. What is the anticipated reduction in traffic volumes on Deerfoot Trail once Green Line is completed?
That's a tough one. I don't think we ever looked at that as a variable. Like all our analysis that we did with the modeling always assumed that the green line was a baseline assumption, and so we didn't look at the effects of green line on Deerfoot. It was more, what are the effects of Deerfoot on the green line.
I just want to add a little bit here, Ken. In our base model 2048, if we are the base model means we do nothing with the future development and the future generated traffic. The base model, we assume that the green line will be totally open in the year of 2048. That's how we build our base model. Thanks.
Okay. Another question from Susan. Was ramp metering investigated?
We did look at
what is the city's province's view on ramp metering? Sorry.
We did look at it at a high level, but we didn't actually test it as in any analysis. But there definitely was a high level assessment done to look at how ramp metering could be put into the corridor, and there definitely is a few challenges on the corridor with definitely some high volume ramps that would be problematic. So it wasn't very simple to do, but through that assessment, we kind of ruled that out as an option, especially for the short term, and not something that I think anyone was looking to consider even in the long term. So that's why it's not recommended in any of the technology applications.
Thank you. Question from Shelley. Will there be further changes to the Pagan Trail? I noticed that there are still many incidents noted in the locations in the slides. Have improvements in the last 10 years made a difference or made enough of a difference to the crash data?
Well, we did make a few changes to the configuration of the Pagan Trail to actually take the jelly bean loop out and put it back to a directional ramp, because we are widening out the highway to accept that ramp. So that was definitely considered in the concepts, but we did retain the intersection of Barlow and Pagan, and much we were looking at things as controlling or metering traffic onto the highway. With this opening up kind of those valves at those intersections would only put more traffic onto the corridor that can't be handled, because we're only really looking at that one lane expansion. So we didn't look at any significant changes to the Barlow Pagan Trail interchange other than the ramp access from Pagan Trail onto Deerfoot Trail.
Next question. Can there be a cost, capacity, safety benefits of reducing the maximum speed to 90 or 80 for current and future years?
We did not consider that. We kept the posted speed or design speeds the same. I think definitely something that I guess Alberta Transportation could definitely look at if there's some advantages, but that was not something that was explored with this study.
Thank you. Are there any more questions? Oops, sorry. Go ahead, Jeff.
Oh, no, I just want to add, today the majority of Deerfoot Trail posted speed is 100 km per hour. North of Pagan Trail, I believe, it's 110. So when we started the project at the very beginning to define the role and function of Deerfoot Trail, we had a workshop with Alberta Transportation, and we decided speed reduction, or saying another way, AT would like to keep the existing posted speed. Thank you.
Question from Mohammed. HOV lanes are recommended along the Deerfoot Trail in both directions. How are you going to enforce that no single occupancy vehicles are using these lanes?
It definitely was a question that came up when we were meeting with this stakeholder groups, especially the Calgary Police Service, about how we were going to potentially enforce these, and are they really enforceable. So we did try to look at some locations on the corridor where some enforcement bays could be considered, and some of the wider median sections up at the north were some opportunities, but we didn't get into that level of detail on this level of study with the HOV lanes, but it's definitely an issue. It's something that we brought forward for considerations as the designs move forward to the next phases. That to have a successful HOV lane, you definitely need one element of the operation is enforcement. Though I don't know, I understand the HOV lane might not be something that actually moves forward, so it might be a moot point.
Question from Jack. Was there consideration of maintaining a direct northbound right ramp from Blackfoot to Glenmore using the eastbound Glenmore service road?
Blackfoot. I'm not following on that one. Do you understand that one, Jeffrey?
No, I'm reading. Was there consideration of maintaining a direct northbound right turn ramp from Blackfoot Trail to Glenmore Trail using the eastbound Glenmore service road? No, we didn't consider that.
The concept that Blackfoot Glenmore is pretty much based on a previous concept done prior to our study, and more or less adopted into our study. So that was done for Alberta Transportation in the city several years earlier. And the whole idea of the Blackfoot Trail interchange is trying to extend out the weaving distance between the successive ramps, so the on-ramps coming from Blackfoot in the eastbound direction to the off-ramps at Glenmore interchange and going to Deerfoot. So the whole idea was to push everybody into that loop ramp so that the weaving distance would be increased significantly. And so that's why the right turn ramp, directional ramp from northbound to eastbound was not considered. But again, a lot of this concept here is really just taken forward from previous recommendations prior to this study.
Thank you. Question from Josh. Did this study rank which interchanges should be improved first?
Well, that's a tough one. Jeffrey, you want to handle that one?
Well, yeah, I will try. We didn't recommend the implementation stages, phase 1, 2, 3, 4, 5, 6, shorter term, mid-term, and long term. Short term is in the next 10 years. 17th Avenue, Glenmore Trail, Anderson Bow-Button, 16th Ave. I believe those are the locations we recommended in the short term for improvement. Because of this whole corridor is huge. The capital cost estimate was huge. Even we broke down implementation stages, in the short term, we are still looking at over 1 billion. Although we recommended where are the immediate locations that needed to be improved in the coming AP P3 project, based on their available funding, they may do some, but I don't think they can do all the recommendations from our phase 1 short-term improvement. Hope that answers your question. Thanks.
Any more questions, comments? Oh, something from David. Thanks for presenting. In the concepts, it looks like Glenmore Trail had 2 core lanes under Deerfoot and Deerfoot Trail had 2 core lanes plus HOV across the Ivor Strong, just south of Anderson. Can you describe some of the factors or benefits, geometric, traffic, or other, that led to the core lane reductions through these sections?
Definitely down at the Ivor Strong bridge. We definitely looked at the overall traffic patterns across that bridge, and the idea there was we had 3 core lanes in each direction as the north-south route. So this is where we're really looking at why our recommendation for collector distributor road was really almost like a highway within a highway, and that the core lanes would be the north-south route, and the collector distributor lanes would be kind of the east-west movements. And so this looking at pure traffic volumes and patterns, the ODs between the the couple interchanges on the south side of the river and the north side, that allowed us to kind of separate and allocate pretty accurately that the demand follows that capacity provided of 3 and 2 in each direction. And then we did test some options, taking the CD lanes further beyond Glenmore Trail. But what we found is that once we got to Glenmore Trail, having more or less a system interchange at Glenmore Trail, things became so complicated between the collector distributor system and the movements between Glenmore Trail, that we decided that to reduce the complexity and the number of structures involved, to terminate the CD lanes just south of Glenmore Trail and just have a more conventional system interchange at Glenmore.
Any more questions? Well, no more questions. I'll say thank you to both Jeffrey and Ken for a wonderful presentation on Deerfoot Trail study. On behalf of ITE Southern Alberta, we'll be donating to Engineers Without Border. I think a token amount of $50, I believe it was. We will leave this chat open for the next half an hour for people to network and mingle if you'd like. Otherwise, we'll be ending this presentation. Thank you.